finding inverse functions, so we're going to find them. Give the domain, range, and graphs of the original and the inverse, and you can use your calculator to help you graph if you want. All of these first examples here are all one-to-one cases. In the next video, I'll do the ones that we have to restrict the domains to make them one-to-one. This is a one-to-one. Yes, it's one-to-one on its domain. This is, oops. It is one-to-one on its domain. Alright, so the first thing is rewrite it as y equals negative 2x plus 10, and then interchange what x and y does. So switch it. So what was x becomes y, what was y becomes x. And then the hard part is, well, now we want to solve for the new y equals expression. Alright, well, that means I've got to isolate y, so the first step is to move the 10 over, so I get x minus 10 equals negative 2y, divide by negative 2, and remember when we divide everything, and so I get negative 1/2 x plus 5, or if you prefer, x over negative 2 equals y, and there's my new y. And so this is the inverse function. So our inverse, f inverse of x equals x over negative 2 plus 5. So I actually prefer the negative 1/2 x, because it's easier, because it's a line, it's just easier to graph in that case. Alright, so there's its inverse. Now I'm going to graph it. So remember, the problem asks us to find, give the range, domain, and range, and graph it. And you can use your graphing calculator. The graph is sort of, and the domain and range is sort of a way to check my answers. It should reflect over the line y equals x. What was any point on, so they should have reflections, right? And so that's sort of why we graph them, is sort of to check our answers. And it helps us get out the correct domain and the correct range. Although in this case, it should be pretty straightforward that domains and ranges are both infinity to negative infinity. Alright, so the first function, I'm going to graph my original. So I'm going to graph the original in blue. And so my first function is a line, goes through the point 0, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did give myself enough. 0, 10. And then the second point, well, I like to pick my intercept. So I'm going to find the intercept. So I'm going to plug in 0 for y and find my x value. So I'm going to get y equals 0. Negative 2x plus 10, 2x equals 10, x equals 5. Alright, so 5, 0. 1, 2, 3, 4, 5. Connect the dots. So there's my original function, which if you graph it on your calculator, it should show up the same way. So there's f of x. Alright, its inverse, so now the inverse, if you remember, the inverse was negative 1/2 x plus 5, and so it does go through the point 0, 5, which that's the check, right? 5, 0 is on my original, 0, 5 should be on its inverse, and it is. And that checks. I plug 0 in, and my inverse, I get out 5. And so the other check is, do I get 10, 0 out? If I plug in 0 for y, do I get 10 out? Alright, and I will, but I'm going to check and make sure I do. So I move my x term, so I get 1/2 x equals 5, multiplied by 2, and x equals 10, and so I do get 10, 0. Which it should, right? In order for these two lines to be inverses, whenever I have a point on my original, the opposite of it should be on my inverse, and so that is the inverse. It does check. So the graph is sort of the way to check it. Right, f of x is the inverse, and domain and range. So I've graphed it. I found the inverse, and so domain and range are infinity to negative. So f of x's domain and range are both negative infinity to infinity. The same for the inverse. Right, they're both lines. Right, And so there's an example of finding an inverse. This is another example. So we're going to get a little harder. We start with a line, they're a little easier. The next one is going to be a cube, and they're going to get a little harder. I'll actually do that in the next video. I think it's easier to do these one at a time.